In this video, I'm going to show you how to graph a parabola. We're going to write it in standard form. We're also going to identify the vertex, the axis of symmetry, the focus, and the directrix. So look at this equation here. We have 4y minus x squared equals 60 plus 12x. The form that we want this in is we want it in, we want it in the form 4p times y minus k equals x minus h quantity squared. And it's obviously not in that form right now. It's 4y minus x squared equals 60 plus 12x. So what we're going to need to do is notice we want this part, we want the square completed on the x. The y is not squared for a parabola. We have y equals x squared or x equals y squared. Either one is a parabola. Y equals x squared is a parabola with a vertical axis of symmetry, and x equals y squared is a parabola with a horizontal axis of symmetry. This one, it's a y equals x squared equation, so it's going to have a vertical axis of symmetry. So it's either going to be pointing up or it's going to be pointing down. Because we have a y term and we have an x squared term. So I know immediately by looking at it, I do know a few things. I know that it's an up and down parabola and not a left and right parabola. But in order to figure out where the vertex is, I really need to complete the square and get it in this form. So let's go ahead and do that. We are going to put our x squared and our x term on the right hand side and put the constant and the y term on the left hand side. So that'll give us 4y minus 60 equals x squared plus 12x. Completing the square, I take half of 12, square it, and add it to both sides. So half of 12 is 6, squared is 36, so I'm going to add 36 to the right hand side and add 36 to the left hand side. And now I have 4y minus 24 equals, and on this side I want to go ahead and complete the square, write it as a quantity squared, and that's going to be x plus 6 quantity squared, completing the square. You can check x plus 6, if you square that, you'll get x squared plus 12x plus 36. So now we're close. On the right hand side, it's the form I wanted. And on the left hand side, all I need to do is write it so that I have y minus something, and I don't want this number in front of the y. I want to factor that out. So if there's a number like 4 written in front of your y, you want to factor it out. So we will factor that out, and we'll have 4 times y minus 6 equals x. And I'm going to go ahead and write this with a minus since that's what's in my form for the equation of my parabola up here. And I'm just going to write it as x minus negative 6 quantity squared. Alright, so now we do have it in the form we wanted. Now this happens to be a 4, and I know there's a 4 in our form. It just worked out that way. This was a nice problem. It doesn't have to be. You could have had a 15 in front of the y, you would still factor the 15 out. Also, even if this negative 24, if that had been a number that was not a multiple of 4, we would still do the same thing. We would just end up with a decimal number here, or a fraction here. So that's all totally fine. You can have, this can be a fraction, it can be a decimal, it can be any real number. We just have to be able to write it so that we have parentheses around this, and we're pulling that number that was that coefficient that was in front of y, we're pulling that out. Alright, so once we do that, we can identify a few things. We know that our center, our vertex, sorry, not our center, our vertex is h comma k, and that is equal to, the x value is negative 6, and the y value is positive 6, so negative 6 comma 6. And let's go ahead and plot that here. Negative 6, 6 would be right there. Alright, that's the vertex of our parabola. And then I can also identify what p is, what the value of p, that number p. Notice that this right here, this equation, this is my equation for my parabola, and it has to be equal to this one up here. So that means, make my pen a little smaller, that means that 4p from my standard equation has to equal 4. And that would happen no matter what this number was. It happens to be 4 here. If it had been 12, then p would have to be 3. It's 4, so 4p has to equal 4. So that means P is just 1. But no matter what this number is, we would just say 4P has to equal this number, and that gives us P. So in this case, P is 1. The value of P tells us how far the focus is from the vertex. It also tells us how far the directrix is from the vertex. So because P is 1, I know the focus is only 1 unit away from the vertex. Remember, we also know that our parabola opens up. So our parabola opens up like this, and we also know that the focus is 1 unit away from the vertex, and it's always on the axis of symmetry. The focus is always on the axis of symmetry. So 1 unit away from the vertex on the axis of symmetry, that tells us that the focus is right here. Okay, the focus is always inside your parabola. So the location of the focus then is -6. It has the same x value as the vertex because it's on this axis of symmetry. So I can draw the axis of symmetry for you. There we go. There's our axis of symmetry. The focus is on the axis of symmetry, and it's 1 unit up from the vertex. So it's at -6, 7. And then we also want to find the equation of the directrix. Okay, remember that the directrix is a line. It's going to be the equation of a line, and it's 1 unit in the other direction. So the directrix is right here. The directrix is always perpendicular to the axis of symmetry. So there's our directrix, and that's going to be at y equals 5. Okay, y equals 5 is the equation of that one. All right, we have our directrix, we have our focus. Notice this is 1, P is 1, so that length is 1. This length is 1. Also, P was +1. Anytime that's positive, our parabola is opening up or to the right. And then the last thing I wanted to find was the equation for the axis of symmetry. And axis of symmetry, we already drew that, and that is right here at x equals -6. Okay, so that's how we complete the square and solve for the directrix, the focus, and the axis of symmetry for a parabola.